Hello, I'd like to demonstrate how to use Powder to conduct a simple experiment showing communication between two software-defined radios using GNU Radio. With a Power account on powderwireless.net, you can follow along and try the same thing. Log into powderwireless.net and choose Start Experiment from the Experiments menu. Select Change Profile to specify the experiment you want to perform. The profile I'll show is called Mobisys21-GNU Radio. After you select the profile, choose Next. At this point, you can give your experiment a name if you want, then choose Next. If the testbed has sufficient radio resources free, choosing Finish at this point will start everything going. If things are too busy, a reservation might be required. You'll need to wait a few minutes while radios and compute and network resources are allocated and disk images are loaded. Once that finishes, you'll get a message saying your experiment is ready. Open the pop-up menu from the receiver node in the experiment diagram and choose the Shell option. This will open a tab within the browser page with a command shell started. Within that shell, please run the command share powder runvnc.sh. This will start a virtual X server you can interact with from your browser. After a few seconds, open the URL in a new tab. If all goes well, you'll now have a basic graphical environment running on a Powder node controlled from your browser. Start GNU Radio Companion with the command shown. GNU Radio Companion is quite a sophisticated program you can use to perform a huge range of SDR functions by manipulating blocks in a flow graph. In this example, we'll barely scratch the surface of GNU Radio by setting up a simple digital link between two radios using PSK modulation. This is the receiver node, and it is set up to receive samples from the radio in a 1 MHz channel at 2.45 GHz in the block on the left. That sample stream is then demodulated with the DPSK block in the middle, and the results are discarded. The raw sample stream will also be displayed graphically by the bottom block. You can start the receiver using the triangle button at the top. It'll take a few moments to install firmware on the radio and then provide various displays of the received signal. Right now it's showing only noise since we haven't started a transmitter. We repeat the shell and VNC steps but on the transmit node this time. The transmitter flow graph is like a mirror image of the receiver. It generates a random digital stream so we have something to send and passes that to the DPSK modulator shown in the middle. The modulated signal is then both displayed graphically in the lower right block and also sent to the radio for transmission at the upper right. When we start the transmitter flow graph, it'll show us the spectrum of the modulated baseband signal. At this data rate, it's occupying about 100 kHz. In the constellation display, we see the samples tend to cluster around 4 corner points corresponding to the 4 PSK symbols we're using. There are also some samples showing the transitions between the symbols. Now that we're actually transmitting a signal, let's switch back to the receiver and see what shows up. Sure enough, the receiver is showing energy in the spectrum right at 2.45 GHz where we expect it. Switching to the Constellation tab, we see a similar plot to what was shown at the transmitter side. The diagram is rotated because of the phase offset between the transmitter and receiver. I don't have time to present further details now, but there are all kinds of things you could extend this basic experiment to do. One fact I want to emphasize is that Powder aims to support experimentation in a variety of environments, and with appropriate tweaks, this PSK demonstration could work equally well in a purely simulated environment, in an isolated RF environment fully under experimenter control, and in a real-world outdoor environment subject to all the inevitable mobility and interference effects. Thank you for your attention, and I hope you find Powder to be useful for whatever wireless experimentation you carry out.